terminal, cd into root. Alright, I'm in the root of this terminal. So I would paste in what I copied from my notepad, Ctrl A V, git clone, repository URL, then personal access token, then add an at here. So press tab. So cloning into, if you have this, you appear to have cloned an empty repository. That means your cloning was successful. You have just cloned your repository. So how do we confirm that? Let's cd into that repository. Let's cd to that repository that we just cloned from github.com. Alright, let's cd into that repository. Ctrl AV, sorry, I believe I copied that. Ctrl AV to paste. Alright, there's no space here. This is the GitHub we cloned from the repository we cloned from GitHub. So that means that repo exists. So let me list files and directory. That repo is empty. Alright, it's empty, not there yet. Okay, so we have cloned that repository from GitHub and we have cd into that repository. Alright, the next thing we have to do now, you can see we have a GitHub repository, then we have a directory. Okay, we have a directory. So I'll just go ahead to create this directory since it is a necessity, 0x00 hello world directory. So I'll copy that name. How do you create a directory? Alright, I know you guessed that rightly. Make directory, mkdir arrow, name of our directory, Ctrl V, I paste that in. So make directory. Alright, if I list files under, you see we have that in our repository. Alright, so I'll go back. Let's look back at our instruction, at our requirement. Pay attention here, please. A readme file at the root of the repo containing a description, then another readme file at the root of the folder of this project. We are creating two readme files, guys. One of them will be in the at the root of ALS low level programming directory, then the other readme will be inside 0x00 hello world directory. Two readme, one in ALS low level programming, the other here. Okay, the other one should be here. Alright, so let me put one here. So how do I do this? I can do this with vi into that, but I prefer to use echo. So echo content of my repo of my readme. I believe no better content should be in there than the project name. You can put whatever you want to put there, it doesn't really matter provided it's descriptive enough. Alright, so I just put in this to AV. Alright, so then that's the sign. I'll write that into readme.md. Alright, that should be written into readme.md. So if I list again, you see I have my readme file. Alright, where should the other readme be? It should be here. The other readme should be here in the directory 0x00 hello world. So let's create that. Let's create that directory. Sorry, let's create that readme. We already have that directory. So let's cd. We already have that directory. Let's cd into alright. So we are now here in this directory 0x00 hello world. So if I list is empty. So let's create a readme file inside this directory. So echo content. For the content, you can put all of this. All right, you can explain, you can put the task names, processor, the other compiler, assembler for the task, and you can explain, give a detailed description, all right, on the questions. But just for the sake of this particular project, this video, I'll use this, just this, though it's not descriptive enough, but let me just use only this for the readme. So copy this. Please, you can go ahead and give your detailed description. All right, you can put all the questions here. You can put all the questions for each task. All right, that will be descriptive enough, but let me just put this. All right, Control AV. That should be written into readme.md. Alright, so if I list again, I have that readme. Alright, so that will be that for the readmes. So we have successfully created those readme files. Let me clear here. So we have created those readme files. So it's now time to start solving our tasks, right? But before then, let's see. These are the resources. This video is not, you ensure you go through the resources. Is very, very important. You will learn a lot. You will learn a lot of stuff from there. Ensure you just go through those resources. All right, so it's time to jump right in. But before then, guys, let me quickly show you a little note here. We'll be coming across a lot of terms, but for this I just brought out this few. GCC stands for GUN Compiler Collection, and integrated distribution of compiler for several major programming languages. And you have STDIO, stands for standard input and output. Then Unix std.h is standard Unix, is a Unix standard header. All right. Then printf function is used to print the text along with the values. So just look through this, look through it, and I believe it's a little guide on some of the terms you come across in this particular project. So we can just move on and start solving the tasks. Alright, so guys, here we have the file names. So here we have the file names. So I could just go ahead and create them individually. Sorry, could just go ahead and copy this file name for the first task. Copy, then vi, Ctrl AV, Ctrl AV, enter into vi, write whatever I want to write as the answer, then escape, exit vi, then save and all that. But I don't want to tour that lane. I want to first create all the files for the basic project at least. All right, I want to first create all the files for the basic project, then make them executable, then start writing the answers into them individually. So we have been doing the first method. Let me show you something. I believe it will be interesting. You want to know that? Let's see that. I want to copy for the basic tasks, the task 0 to 6. I want to copy all the files. copy like this, copy this. I want to copy all of them. All right, and this I'll copy this, copy. I'll copy all the file names. See, I get to copy down to tag 6. Copy down here. So if I do that correctly, I should have this. Alright, if I copied all of them correctly, I should have this for the file names. I want to create all of these files with just a single command. So to create a file, which command do you use? You use touch, right? Touch. So I want to create all these files just in one line. So touch all these file names to create all of them. So I'll copy this. Head back to my terminal, Ctrl A V, I paste that in. Alright, I paste that, touch all of this. So if I list, you discover that all these files have been created with just a single line of command. Believe you understand that. It's just a fast method of doing that. So you can try that out in your own coding when you are writing your project. So since I've created that, again, I can individually chmod u plus x and make them executable, but again, let me use a single command to make all of these files executable files. I can do that. Chmod, which stands for change mode, a plus x, then space, put the star. Alright, you hold your shift to do that. Hold your shift and tap the 8 button, alright, on your keyboard. So if I press tab, I list, you discover that all of them are executable now. So I believe that is interesting, and you have learned something today. So you can try that and practice with that. So that is that. So let us now start writing the answers on the individual files. So are you ready for that? So we go to the first one, P0 preprocessor, copy that. VI, we are using VI, please, Ctrl A V. Alright, so that is that. So I tap insert to write into VI. Alright, it's active now. So what are we expected to do here? Let's read the question, right? The question always guides us. Write a script that runs a C file through the preprocessor and save the result into another file. So for this first task, guys, and for a few others after now, for this first one and a few others, I think to task 3, we are going to be writing shell script. So we have not just started writing the C program yet. All right. So for a few of these tasks, we are going to be writing shell script. So this write a script. So this is writing a script. So to write a script, they gave an instruction here. So for the shell script questions, they said all your files should end with then the first line of all your files should be exactly this. I believe the other project we did on scripting, writing script, you are used to this hashbang command, bin bash and all that. So let's do that. So the first line will be this compulsory line, since you are still writing a script for this question, bin bash start. So then we put the answer to that question. Write a script that runs a C file through the preprocessor and save the result in another file. To do that, we are going to use the gcc command. And before now, I showed you some of the little content write-up I did. gcc GUI compatible compiler. All right, we are going to be using that command. Then it's a write a script that runs a C through the preprocessor and save the result into another file. So to do that, going to run gcc. Since it is a script that runs a C file through the processor, we are going to be using the hyphen capital E command. I will explain that in a short while. Then we put in a $sign C file. The C file name should be saved in the variable D. So we have inputted the variable name the C file should be saved into. Then we are going to output this. Look at this. The output should be saved in the file C. Since we are outputting, we are going to use hyphen O. O stands for output, and that output should be saved into the file C. All right. I know you are wondering, how do you know that you are putting A here, you are putting and all that? Let me show you something. Come here, look at this. GCC, let me expand this. gcc.gnu.org. all right, when you, I'll leave the link in the description. When you go to this website, it's going to show you, there are commands here. So this is the documentation for GCC. So the commands we are using, I just used E. So this is where I got it. It's not something that you cannot do. This is just where you get all of these commands. So for E, it stops after the pre-processing stage. So, and if you look at our question, it talks about write a script that runs a C file through the preprocessor. So for preprocessor, writing a script through preprocessor, you use the hyphen, you put the E command. So that's just that. So you can go through that documentation. It's going to help you a lot. All right. So I believe this is correct. All right. Believe we have done this correctly. GCC E, then preprocessor. We are doing we write it to the preprocessor. A script through the preprocessor. Then save the result to another file. The file name should be saved to the variable this. We are outputting. O stands for output, and we are outputting it to the file C. So that's just that. So escape column WQ. I get out of that. Okay. Aha. Let me quickly show you something again. You see where I tried to output. I know, so you might be facing a similar challenge when you try to get out of VI. Then your terminal will be below. To solve this challenge, what you need to just do is to type clear. Once you clear this out, clear is going to return to normal. So you see that. So I believe you have learned something again. So that's that. Since I've done that correctly, I'll just do git add, git commit -m, commit message, then okay, then git push. All right, so we have pushed successfully. Let me clear here. Then let's go back and check our code to know if we are correct. So let's check again. Oh, I don't know why it's starting. Okay. sometimes it can be tiring. Let's allow it to run in the background. I believe it's checking. So okay, it's checking, so it will run in the background. When it's done, we'll come back here. So we move to the next task. Write a script that compile a C file that does not link. So let me copy the file name, copy vi into av, that file name. So we have to write our compulsory first line, bin bash, then how do we write a script that does not link? Can we check this again? Still running. Believe it's some network on the terminal. Believe that should be on their part, but it's absolutely correct. Let's just allow it to continue checking. So a script that does not link. So again, look at this documentation, how to write a script that does not link. Look here. So look at this C, compile or assemble the source file but does not link. So to write a script that does not link, you use this after inputting your GCC. So that is just what I want to show you. So please go through this documentation. It's very, very important. It's going to guide you. So after putting our first, we are going to use GCC again, then C, then the file name, which is $C file, $C file. So this is how to create a script that does not link, and you know where we got the source from. That's that. I believe this is correct, writing a script that does not link. Alright, so let me exit. Let me get out of VI. So I will just do git add, git commit -m, commit my commit message, and I do git push. Git push. So push successfully. I believe this is correct, but let's go back and check if we did the right thing. So okay, our first code has been checked. I believe this is correct now. Alright, so let's check this too. So this is all correct. You can see that it's all checked. That means we are correct. So let's go to the third task, number 2, assembler. So before we read it, let's first copy the file name, copy vi, paste that in. So since we are writing a script here, insert, going to write that first line, bin bash, So the question, let's go back. The question says, write a script that generates the assembly code of a C code and save it into the. Write a script that generates the assembly code. So how do you do that? If you look, we use the GCC command again. This time you are going to use the cap S. Your documentation will guide you. So the cap S, then C file. So that is how to write a how to write a script that generates the assembly code of a C code and save it to an output file. Alright, this is just the command to do that. This is the command to do that. Alright, I believe this is correct. So since we are done with that, let me exit vi column wq. Alright, so we can git add, git commit -m, a commit message, git push. Alright, done successfully. Believe this is correct, but to clear any element of doubt, let's check our code. So this is correct. You see it's all checked. That means you are correct. So we move to the next theory name. Write a script that compile a C file and create an executable named this. A script that compile a C file. Now, how do we do that? First, let me copy the file name. So vi file name, tap I to enter a start mode, hashbang b bash, so to do that we are going to use gcc, then the script that compile a C file and create an executable named this. The file name will be saved in the variable. So we are saving the file name in the variable what? $C file. $C file. So we are saving that into the variable name $C file, and compile a C file and create an executable named C is fun. So we are outputting. To output we use O, and the name is C is what? Fun. C is fun. C is fun. So I believe that is correct, done correctly. So I exit. Git add, git commit -m, commit message, then we git push. Alright, let's check. Okay, it's checking. Believe it's let's allow it to run on the background, and so that we can quickly move to the next task. So the next task is hello put write a C program. So this is our first C program we'll be writing in this project. All before now we are writing scripts. So we are writing a C program now. So let's do that. I believe you are excited. You want to write your first C program. Vi file name. So we are not going to include the #bang command, bin bash and all that, because we are no longer writing a script. I believe that is clear enough. We are writing a C program right now. So to write a C program, what do you need? You need the header. So you need the header. So how do you input the header? To include the header, what do you use? You use hash command include, sorry, that should be in lower cap, include include then you put your less than sign, std, like I said, stand for standard input, output, IO stand for input and output. Then since I put a header, we use dot header. All right, then we close that. So this is the how to include the first line of, to include the standard header, you use this. All right, again we need something here. Okay, our C program requires a comment. All right, a comment. Remember, we are for this for writing this C program, they gave us some requirements or some conditions to fulfill, to follow strictly. Your code should use the Betty style. It will be checked using Betty style. So our code should be Betty compliant and it should follow Betty documentation. So as part of the Betty documentation, you have to include comment. All right, you have to include comment. So, and we are writing a multi-line comment. So to write a multi-line comment, you do this. Put your asterisk sign, two of it, so that when you tap enter, it generates one asterisk for me. And here I'm going to type main. All right, main. What does that main do? I'm going to, that should, the comment of how I did my project, what the project is all about should go into the main. All right, some can go ahead and write entry point here, entry point, and just continue. They'll go and write the return value. But I want us to not to that lane. So for the comment section, your comment is supposed to show what you did, how your project, what you did about your project requirement, and how you went ahead to solve those requirements. So for this particular problem, it's a write a script that prints exactly this. So a comment, I want us to put, you can put whatever you want to put there, but ensure that there are no white spaces and it is Betty compliant and follow the Betty documentation style. All right, so for this, I want us to comment this way: a program that prints a line with puts function. So I want us to use this. I think this is descriptive enough for the main, a program that prints a line with puts function. Alright, so let us be very strict so that we will follow the program will pass the Betty test. Alright, so have we done that? I move down. There's also another requirement for the documentation. After main, it is return. Okay, so I'll type in return. Ensure you put that colon. It's very important. If you don't put that, it will pass the Betty test. Okay, and passing the Betty test is one indication that you are correct in a way. Okay, so before you even check your code, Betty will check you first. Alright, that's just the meaning. So look here, use the function that you are not allowed to use printf. Your program should end with the value 0. So our return value should be what? 0. You can end it here, but I will just go ahead. I like making things very descriptive, that when our program returns the value 0, that means this whole project is a success. All right, you can say return 0, that will be fine, absolutely, but I want it to be descriptive enough. So when it returns 0, this whole thing is what? A success. So close that. Sorry. So I close that documentation part. Press tab. Then after the comments, then we write our program now mainly. All right, to do that we do int, and int stands for integer. Okay, int stands for what? Integer. All right, so we do int main, then we put void. Please, if you are confused, I will do a little explanation about this. Okay, remember the question said write a program that prints exactly this line followed by a new line. Use the function put. You are not allowed to use printf, and your value should end with 0. So you are not allowed to use printf. Use the function put. So we are going to do that. We are going to give a function a name to our function. All right, we are going to give a name to our function. First, we do a function declaration. So this line is about that declaration. This line helps us declare our function. So this is telling us that our function, this integer, and the function name is main, and the output should be what? Void. So this is a function declaration line. All right, I believe you understand that. So this line helps us declare our function. So after doing that, you are going to put in your curly braces. Put in your curly braces. Then you are using puts. They said you should not use what? You should not use printf. So they said that print exactly this line of code. So I'm going to copy it. They say exactly. So let's copy. The best way is to copy so that you won't make any mistake when you are typing out. So Ctrl AV. All right. So that prints exactly this, followed by a new line. So this is what we are printing, but for a C program, the convention is that, okay, first let's close this. All right, let's close that bracket. The convention is that when you are writing a line, when you are writing a line, you have to you have to wrap it up with a double quote. You have to wrap it up with a double quote. So, but here in this question, we already have just one double quote, which is here, so which we copied already. So since we have that, and we must include a double quote, a pair of double quote in our line. So let's put that pair of double quote. This is the first one. We move down here. Come down here. That's the second double quote. All right. But look here, there might be a challenge here, because since what they ask us to do, there's already a double quote, a single double quote there, and for this program it requires that we add a pair of double quote to whatever line we are printing after putting the bracket. Then there's a problem here, because this, you see, there's a little challenge there. So how do we escape this? So to escape this, you are going to use this is now a special character. All right, this is a special character. So to escape that special character, you are going to use, what do you use? You use a forward slash. Okay, to escape that special character, you use a forward slash. All right, you see our program, our line has turned red again. That means we have done the correct thing. To exit that special character, you use a forward slash. So have we done that? So I believe this is correct. Are we done yet? Not just yet. So the last thing we do right now, is to put in okay, after this, put a colon, a semicolon. All right, that's just the pattern, a semicolon. Then after that, our whole project should return what is it returning? Return the value 0. All right, it should return the value 0. Okay, so return the value, 0. So we put our semicolon there. All right, then remember, we need to close our curly braces that we open. So look through. So we have to check to ensure that there are no white spaces by going to the end of each line. Ensure that there are no white spaces. We look into white space, because Betty does not allow white spaces. If white spaces is in your program, it's not going to work when you test with Betty. So let's just escape. I believe this is correct. Colon WQ. So let's test with Betty, because they said our code must be Betty compliant and follow Betty documentation. So to test with Betty, you type Betty, define name, Betty, define name. So that should be put, copy, Ctrl A. All right, so if you at the end of the day, when you trying to test with Betty, you have this, it comes out exactly like this without an error message. It means you passed the Betty test. So congratulations, for this we have passed the Betty test. All right, so let's do git add, git commit -m, commit message, then git push. All right, so it's time to check our code. For passing the Betty test is one indication. It's an indicator that your code should likely be correct. All right. So you see, it's all checked. All checked. So that means you are correct. Like I said, when you pass Betty, very likely your code should run correctly. So move down to the next one. Write a program, printf. Alright, so copy this. Okay, let's clear a terminal. vi Control AV, I paste that. Alright. Top right to enter a start mode. So to start our project, like you already know, we include the standard input and output dot h, stand for header, standard input output dot h. Alright, then what else? We put in a comment. So what should be, we have a main for the comment. What are we putting in there? I want us to write a C program that prints exactly. So I'm typing a program that prints a program that prints a line using the print. Are we using printf? Let's confirm. That print a line, it said use the function printf. You are not allowed to use put. So using the printf function. Using the printf function. So having done that, press enter. Then the return. Put colon after return, colon. Then what is it returning? It said look at it, your program should return 0. So I'm just going to type that in here. Return what? 0. Alright, and for convention, if you return 0, is it a failure or is it a success? If you return 0, for me that means it's a success. So I put that in. Alright, so I believe our documentation is, our comment is in order. Alright, so we are going to close that comment section. We're going to close that comment section. Then we move to the main part. So after comment, what do we do in the next part? We include our line that declare our function declaration line. All right, declare our function. That will be int, integer, then main, function name, then it should be void. All right, then after that we open our curly braces. Then our function should print what? Printf this is the line. Print exactly this line. To this point. So I copy that. Control AV. I paste that in. It's printed that line. Remember, since we are printing a line, we have to add we are adding a double quote. All right, double quote, a pair of double quotes to the beginning and to the end of the line. We add a pair of double quotes to the beginning and to the end of the line. All right. So close this. What else? Then it said followed by a new line. So how do we do that? To do that, a new line will be signified by what? By n. But if I type in this n, you discover that this n just look like every other character, on this in this content of this n. So the compiler does not understand that as a new line. It just take that as every other character. You see, they have the same color. So I have to, again escape that n and indicate that, oh, this should not look like every other character here. All right. So to do that, I'll use what? Again, I'll use my forward slash. So you can see that. So n now look different. So that is what we are supposed to do there. All right. So print f, the content, then that. I'm just making sure I don't have white spaces. Betty does not accept that. So what are we returning? We are returning the value. What? We are returning 0. All right. So I do that. Then press tab. Press tab. Then I have to close off my curly braces. I do that. Okay, I believe this is correct now. Standard input. Just checking to make sure that there are no white spaces. To check, you have to go to check for white spaces, go to the end of the line and make sure if you use your backspace, make sure that the backspace is exactly at the end of the last character. There shouldn't be any space at the end of the line. All right. If there is, that will amount to having a white space, and Betty does not accept that. Okay, so return 0. I think that should be correct. I believe it should be Betty compliant and follows the Betty documentation style. So column WQ, I get out of that. So let's run Betty. Okay, say no argument passed. Betty print. Okay, one error, trailing white space. What line? Line 12. So we have a trailing white space on what line? Line 12. So let's VI Control AV. So please listen attentively so that you will know how to solve this trailing issue of trailing white space. So we count. They said we have a trailing spaces on what line? Line 12. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So let's move there. Okay, I have to insert to write into this. So remember, we are trying to solve the issue of trailing white space. I told you before, Betty does not accept that. Okay. Trying to locate that, but note that if they say line 12, you have to check upward from line 12 so that the trailing spaces might just be hiding somewhere else. Alright, so okay. So let me escape colon WQ Betty. Oh, still have that. Betty is very strict, guys, on trailing white space. So VI AV. Let me go back. Alright. Let's count again. 1, 2, 3, 4, 5, 6, 7, 7. Betty is very, very strict. Okay. Please look I said move to the end of the line to solve issue of white space, and if there is any space there, please remove it. Alright, still working on this. Okay, so I believe this should be correct right now. So hold on, WQ. So that done. Alright, so let me just pick this up. I believe that is correct. So let's check from here. Check code. So it's all checked now. So that means we have been able to pass that. So I close. Let me clear here. Alright guys, let's move to the next task, which is this. Size is not grandeur and territory does not make a nation. So write a C file, a C program that prints the size of the various that. Alright, so let me copy this, copy paste that. Alright, anti-sack mode. We put in our include standard input and output, include what? Standard std input and output. Then .h, this is to show it's a header file. Then we put in our documentation. It should be double of it. That should be double of it. Should be double documentation. Then we are going to write. We should have our main hyphen, and what are we describing this project as? Write a program that prints a program that prints the size of various types, that prints the size of various types of computer let me just read that once. Don't like going back and forth. Size program that prints the size of various types on the computer it is compiled on. Various computer types. Various computer types. So I believe that will suffice. So I move to the next to write the return value, the return. The return should be 0. Alright, then if it is 0, that means it is our project is a success. Alright, it's a success. Then that should be the end of that. So for this, we are going to please look at this a little different from what we have done before. So they said you should do as in the example as above. You should produce the exact output as the example as above. So they said our output should our output should look like this. Alright, we have here character, integer, long int, long hit, and a float. So they said our output should look like that. So that is exactly what we are going to be doing. Alright, so to do that, we are going to do as usual, integer, that should be main, and inside that bracket we should have what? Void. Okay, we should have void. Then we have curly braces. We have our curly braces. Should have our curly braces. Then after that, we are going to write into that you see what I read from here. We have character, init, long integer, long integer, and float. So I'm going to initialize that. Character should be I'm going to give character the variable name a. Alright, then integer, I'll call it b. Then long integer, I'm going to call that c. Long integer, that will be d. Alright, long integer, that will be d. Then our float, I'll use f instead of e. I know sequentially it's supposed to be, but I'll use f, stand for float. That will better, that will suffice for that. So after that, I'm going to go down, give a line, please, considering giving a line. Then we are using printf. Then what are we printing? We are printing, come back here, let's look here. They said our code should look exactly like this. So we are taking this as, so print the size of a character size of an integer, size of long, int, and size of float. So that is what we are going to put in here. So just look at what I will do here. So this is what they expect us to do. I'll copy that, but it has to be in double quotes. So Ctrl AV, size of a character, alright, colon. Then after that, I will do something here. I'm going to use, okay, let's see our documentation to know if we have something similar. Okay, look at that GCC, our GCC website. That's where I am now. Our GCC website. Alright, I'm trying to look for percentage ZU or LU. Okay, I think you can search the entire documentation if it's not on this particular page. Alright, you can do that. Let me just go back. I wanted to show us something, but I can explain that orally. Okay, we are going to use the percentage symbol. Alright, LU. So what LU signified is unassigned long. Alright, you can decide to use ZU. That's another way to do that, but I prefer using LU, unassigned long. Alright, that is how to put that in. LU stands for unassigned long. Alright, then after that, look here, you have bytes. So they expect us to do this too. Okay, so I'll copy that. After the unassigned long, I'll paste that bytes. Then I'll paste that in, then I'll put in that. Then I'll put in that. Then after that, after that, I'll put my forward slash. I'll put my forward slash. Then I'm going to indicate that this is an unassigned word. Like I told you, it's an unassigned word long. Alright, so you see that changed to a different color. That means it is a reserved word, unassigned long. Okay, then after putting in that, again I'm going to bring in size of. Okay, believe that is a reserved word too. Size of. Size of. Just a second, it's slowing down. Size of. So since we are in the first one, which is character, okay, we are going to use size of character, we initialize it with the variable name a. Okay, size of a. Then we close the whole bracket. So at the end we put a semicolon. So printf size of a character column, then we use this unassigned long command, then followed by byte, which they gave us. When you look at what they said we should print exactly, then for that should be in a new line, of course. Then we have comma, then space, unassigned long, then size of. Size of, let me just go through this. There shouldn't be a space there. Size of, okay. Size of. Alright, so you see that's a special. I did type it. I typed double off. That's why I changed. So this is a reserved character, size of a. Okay, so for the next one, I'll just simply copy this first line and change the different types. So we have done for character. So we do for init, long int, long int, and float. So let's hope I'm able to copy this. Okay, I'm coming. Let me just expand this. Oh, sorry about that. Copy. Copy this whole line. Copy. Control A. Oh, I didn't copy that correctly. Let me copy again. Copy. Control A. Okay. It's really giving me challenges copying this, and I really need to use this. Okay, let's see if I can come here to note. I'll need to copy that. It seems my terminal is giving me challenge copying. Okay, that means I'll have to type it all out. I never wanted to go through that long process. Let me try this once again. Okay, it seems when I press C, it cannot. Alright, so since we can't do that, let's just type it all out. Print F type in size of int for this. Okay, size of int for the next one. Copy that. Control AV, paste that. Then I put my percentage LU, then bytes. Copy this, copy, and I paste that here. Control AV. So I paste that byte, then I'll followed by my /. That should be in a new line. So I do that, my comma, then I have my unsigned long, then I have size of B. So that is that for the second one. Alright, printf size of an int LU bytes in a new line, unsigned long, that's this, then size of B. Okay, so for the third one, again we go again, since we cannot copy that, unfortunately. Copy size of long int, copy that, Control AV, paste that, then percentage LU bytes, I have a /. Okay, shouldn't be a space here. That should be in a new line, followed by a comma. Then we have a assigned long. Close that up, and size of C this time, C. So I close that. Alright, so that should suffice for that. Then for the next, I do printf. Okay, for this, let me copy size of long int. Size of long int, and percentage side long, then bytes, /. That should be in a new line. really wish I was able to copy that, but I'll check that out at the end of this video to know why I was unable to copy. Side long, that for long int, that will be D. So D and that. So put in colon. Okay, our sign is showing us sign that is not correct. So let's type that rightly. SIG, there should be a G there. Alright, it's correct now. So that is that. That should be D. So the last but not the least, printf. Copy this size of float. Copy. Control A V. Paste that. Okay. Percentage value. No. Value. Bytes. Then / new line, close that off, unsigned long, size of F, close that. So alright, I had to just type this. I really wished I was able to copy this first line and just change what I needed, but we are done now with that. So you can look through. Please input this exactly what I did here, alright, into your code. Alright, just do this exactly. Okay, so if you have done that correctly, then the last return, what are we returning? Here we have to return this. Your program should return 0, so I'll quickly type that in. Our program should return 0. So we put our curly braces. Alright, put in our curly braces, and I believe that is all done. First is character int long int, C long int D. Then we have float, which is F, and that is that. So we escape colon WQ, press that. Alright, like I said, we are having this. If you are having this challenge, your VI and your terminal are, struggling to be on the same page, just do clear, and that will solve that. So that's that. So we quickly, okay, let me quickly git add. Our time is fast spent, we really need to rush this. Git commit, -m. I don't know where it's playing down right now. Git commit that's closed. Wow. Okay, no cause for alarm. We just have, I think, 1 or 2 projects left. Let me just quickly get another sandbox. Sorry about that. I think I had a call, so all right. Let me quickly get. Let me quickly get. Okay. So cd alx. Let me quickly rush this. Sorry about that. I think. Copy. cd. Control A, B. Control A, B. One. I believe that is where we are. To be sure. So let me cd into hello. So hello world. cd into this. Control A, B. So if I do this. All right. I believe that we are in the right place. So let's quickly go back to where we are before our terminal was closed. vi, I believe we are here. Size of that, so vi this. Copy this. Control A, V. All right. So this is where we were. All right. I believe this is correct now. So escape. Hold on. WQ. So I do git add. Git commit. -m. Paste. Git push. To make git push. All right. So believe that's correct, but let's confirm by checking our code. So if we check, so it's all checked, that means we are correct. See, it's all checked. So I close this, we move straight to the next task. Write a script. So we are writing a script again this time and not a program. So I'll copy this. Copy, Control AV, then okay, VI, VN, Control AV, I paste that. Alright, insert. Then it said write a script. Our question says write a script that generates the assembly code this of a C code and save it in the output file. So you remember our compulsory first line in bash. So we are going to write a script that generates what? I don't know why this keep going down. We are here. Keeps moving down. Alright, write a script that generates the assembly code instead that. So I'm just going to write that. Already pressed with time. I don't want this video to be too long. So that will be that. I'll just write the command. Please, you can just look through, read your documentation. So the command to do that is that s masm that will be equal intel. So write a script that generates the assembly code in 10 syntax of a C code and save it to the output file. So we are this will help you do that generate the assembly code. To generate, as you remember S, if you go to our documentation, stop after the stage of a compilation, do not assemble. The output is in the form of an assembler code file for each. So S help us do that. Please always refer to your documentation, GCC documentation. It is very helpful. So C file, so that will be that GCC hyphen capital S masm intel that save into the file $sign C file. So exit column WQ. So I do git add git commit -m Ctrl-AV file name, git push. Git push. So that will be that for that task. The last but not the least, Unix. Write a C program that prints exactly that. Alright, so that is the last task. So we are going to work on that right now. So let's, the file name is what? This is the file name. So I'll copy that, Ctrl C, then I'll come here, Ctrl AV, I'll paste that. Okay, no, I'll do VI. Alright, so I'll do that, enter VI mode. Alright, to do that, remember we include include st standard input output dot h. we are including again first one is include standard input output for the first header. Then we are including Unix UNISTD. I will explain shortly why we are doing that. Unix std.h. So why in the previous tags we included just this line. So why are we including this? Meanwhile, this stands for Unix standard header. That is Unix standard header. So look at the question. Unix is basically a simple operator. You can have to write a script that prints exactly this, followed by a new line to the standard error. So we are working on Unix, all right? So you have to include both of these for it to work. We are working on Unix, right? So you have to include both of these for it to work. All right. So that's that. You have to include both the standard input and output and Unix standard header. Okay, so have we done that? What else? We write our comments. That will be main. What does this program do? Just write a C. I don't want that to be a cap. A C program that prints a line. Then to the standard to print a line to not typing that right to the standard error. So that's what I want to put in there. So then our return, look here, they said the program should return what? 1. Look at it here. Program should return 1. So program should always return 1. And if it returns 1, I will deem it as successful. Okay, so that will be that for main and return. We move to include our integer main void, close that, then put my open curly braces, fput, you are not allowed to use any function listed in the name section of the main print of man put. So since we are not allowed to use printf and put, we use what? Fput. Take note, fput. All right, then what are we printing? We are printing exactly this line. Copy that, copy the line. So I put my double quote, Ctrl AV, paste that in. After pasting that, so there is a special character here, which is this. Let's go back. We have to exit that special character. Can you see that dash or hyphen? Okay, this quote here, this what is it called, double quote here, this double quote before the hyphen, we have to exit that by using what, the forward slash. Alright, so you can see everything now has changed to red, color red. So after this, printed in a new line. So to print in a new line, we put n, then we escape that n to show that it's special character. Then we do that. So this should be standard output. Alright, standard output. Okay, so close this, and we put our column there. So f put what we expected to put in here, then we escape this, hyphen dora copper thread dash, we put our new line, we escape that, then standard what, output. So that is that. Then lastly, sorry, return. Our code is supposed to return what? Return 1. And if it returns 1, okay, return 1 this time, not 0. After doing that, we close our curly braces. So I believe this is correct. So I will quickly git add, git commit, and git push. I already did this, so this should be correct. You know, I'm already pressed with time, so I needed to just do this last one so that it won't be a problem for you when you are trying to do that. Alright, so for me, I believe there are no white spaces, so they just look through. If you have any other question, you can drop it in the comment of this video. This video is too long already, so escape colon WQ. I'm just trying to beat time right now. So one thing I want to do, I want to chmod again, make all of the file executable in case there are some that did not that are not executable. U plus a plus x, then put my star asterisk chmod plus x. So you see all are executable. So let's do git add, git commit. Like I said, if you do this, it's definitely going to work, but if you have challenges, drop them in the comment section. I'm going to address that. I'm already pressed with time doing Betty and all of that. So go to AV, sorry, I'm pasting the file name as usual, so not this. File name is this, so copy, Control A, paste. Add, git commit, okay, sorry, Madi again. I've committed, right? Yes, I've committed. I do git push, alright, so that has been pushed, and I certainly believe that that is correct if you follow through with what I did. So if you checked. So you see, for that last task, it's all checked. That means you are correct. But if you come across any challenge, like I will always say, drop them in the comment section. You know, drop any challenge in the comment section. Ask any question you have in the comment section. I'll definitely reply to them as soon as possible. Alright, please, if this video helped you in any way, kindly like and subscribe to this channel. Please like, subscribe to this channel. I'll bring more content, similar content, to guide you, to help you in your programming journey. Thank you so much. See you in the next video.